Hello everyone, myself Vikas S. Kumar and I'm studying in Trachura College of Engineering. Foursome branch is ISC and the subject is ADA. Topic is Knapsack Algorithm. Introduction to Knapsack Problem. The knapsack problem is a classic optimization problem in computer science. It involves maximizing the value of items selected from the set of items. Subject to a weight constraint, this problem has application in diverse fields such as resource allocation, logistics, and financial planning. Defining the knapsack problem. The knapsack problem is a fundamental optimization problem where a thief or a hiker needs to choose an item to maximize the value of their loot or their backpack contents, respectively. The 0 by 1 knapsack, each item can be either fully selected or left behind. There is no partial selection allowed. Fractional knapsack. Item can be partially selected, allowing the thief to choose an item to maximize the value within the weight constraint. The knapsack algorithm in EDA. The knapsack problem is solved by dynamic programming techniques. Dynamic programming breaks down the problem into smaller subproblems and solves them in a systematic way. First one, initialization. Create a table to store the maximum value achievable for each weight up to the knapsack capacity. Iteration. Fill the table iteratively considering the value and weight of each item and the current weight limit. Backtracking. After the table is filled, trace back to find the optimal combination of items that maximizes the value. Implementing knapsack algorithm. Implementing the knapsack algorithm in EDA involves using data structure such as an array and loops to iterate through the items and calculate the maximum value achievable for each weight. Algorithm. Greedy algorithm selects item with highest value to weight ratio first. Dynamic program uses a table to store the maximum value achievable for each weight up to the knapsack capacity. Time-space complexity. The time and space complexity of the knapsack algorithm depends on a specific implementation and the size of the input data. Generally, the dynamic program approach has a time complexity of 0 nW, where n is the number of items and w is an accept capacity. Time, time complexity 0 nW for the dynamic program approach and space complexity is also the same. Optimizing Knapsack algorithm. Optimizing the Knapsack algorithm can improve its performance and reduce its computational demands. Techniques for optimization including memorization to avoid redundant computation and reducing the size of each search space. Memorization stores the value of subprograms to avoid recalculating them. Branch and bound prevent to search tree by eliminating subproblems that can lead to an optimal solution. Handling constraints in knapsack problem. The knapsack problem can be modified including additional constraints such as item dependencies, deadlines, or volume restrictions. These constraints need to be incorporated into the algorithm to achieve an optimal solution. First, item dependencies. Certain items may be only selected if other items are also included. Deadlines. Items may have deadlines, adding time constraint to the problem. Volume restrictions. The knapsack may have a maximum volume limit in the addition to weight limit. Application of knapsack algorithm. The knapsack algorithm has a numerous application in real-world scenarios. It can be used to optimize resource allocation, logistics, and financial planning. Logistics, optimizing delivery routes and packing vehicles with goods. Financial planning, selecting investment with the highest potential return within a given budget. Resource allocation, limitations and challenges. The knapsack problem can be computational complex, particularly for larger input size. Additionally, it can be challenging to handle in real-world constraints that are not easily molded in the standard problem formulation. Computational complexity. For larger input size, the time required to find the optimal solution can be significant. Real-world constraints. Modeling complex world constraints are quite challenging. Conclusion and features of consideration. The Knapsack problem is a fundamental optimization problem with numerous applications in various fields. Future research direction, including developing more efficient algorithms for handling larger input size and complex constraints, as well as exploring application of a problem in emerging areas such as machine learning and artificial intelligence. Thank you.